Okay, so on Monday we talked object-oriented programming, and we looked at S3. And S3 is R's primary object-oriented system. And I had prepared a whole bunch of slides, and we kind of ran out of time. And so I'm just going to cover this real quickly. And the rest of this the presentation, I think you can go through on your own. I've set it up kind of like a self-quiz, okay, covering method dispatch in S3. All right. So regarding inheritance, basically, it there's a function called S3 dispatch, and I've chosen to remove the slides covering next method just because it gets a bit complicated. I didn't want to, I'd have to stretch this out over 3 days of lecture, and I'm opting not to do that. Okay, so basically, you can look up, how does when you call print on a factor where you say ordered equals true, what is it being called? It looks up print.ordered, and then there's no print.ordered faction, okay? So or print.ordered method, so it runs the print.factor method, okay? And we got subclasses and superclasses, and so I've arranged this kind of like a self-quiz, and you can kind of go through, and your first question is, what is the result of f called on k? Okay, so k is the number 1, and we have defined f dot.j, f dot k. Okay, f is a generic function using use method f. Okay, and this is not written with good style, but just for simplicity, these are one-line code, so I've opted to write this. Okay, so any guesses for what this will return? No guesses? This returns an error, okay? Because we have defined f as a generic, but k is basically, this is what it searches for. It's going to search for f.double, f.numeric, and f.default, and none of those functions exist, and so it says there's nothing to do there, okay? Here, if I've defined k as class j, and I'm going to call f on this value k here, which has the value 1, and so this will return what? 3, right? So it takes 1 and it calls the f.j method, and it does x plus 2 and it returns 3. Okay, it also prints out some extra stuff here, and then it says this is what it would have searched. It searched f.j and it found it, so it ran it, but then it would have also looked for f.default. Okay, anyway, all of these slides, there's a whole bunch of these set up this way, and you can kind of go through and check your understanding and quiz yourself, which I recommend that you do. Okay. All right. But today we are going to talk about the R6 object-oriented system. All right. I guess I should just double check and see if there's any questions regarding S3 stuff before I move on to the R6 stuff. All right, I will move on to the R6 stuff then. Okay. All right, so the R6 object-oriented programming system uses encapsulated OOP, okay? And so this means that methods belong to the objects themselves, and we would call them kind of in this form object $method, okay? R6 objects are also mutable, and they have reference semantics, and we'll cover what that means in a little bit as well, okay? So we don't have generic functions, rather the functions or the methods belong to the objects themselves, okay? And so to get started, you've got to do install.packages R6, and then you call library R6 to get it loaded. All right, so when you use this, okay, you create a new object class in R6 using this function R6 class, all right? And that's all you need to use. This is the only function from the R6 library that we'll use. This is going to implement all of the reference class system, okay? And when you define a new class, there are, you got to give it at least two arguments here. You should give it a class name, okay? And then you give it a list of public fields and methods, okay? So class name, and then just kind of convention is you use upper camel case. Upper camel case means if you've got multiple words, you don't separate them with underscores, but you just capitalize the letter, and upper camel case means the first letter is capitalized. And then the values in public, okay, are fields, and if you have multiple words, use snake case, which means use an underscore to separate the words, okay? If it's one word, you don't need to do anything, okay? And then you should always assign the result of R6 class to an object, okay, or variable name with the same name as class name, okay? And the result will be an R6 object that defines the class, okay? So here, this is a very, very simple example of an R6 class, okay? And this I'm taking straight from Hadley Wickham's book, okay? So I'm taking all of his examples from there, and then I'm just kind of adding some of my comments here to add more exposition, I guess. All right, so here we've got, we are defining an R6 class. The class name is accumulator, capital A, okay? Capital A accumulator, that's the upper camel case. And note that we assign the result of R6 class to the variable name accumulator, same exact spelling as this, okay? And that's kind of important for this. And then for public, we have a list, okay? So what you provide public is always going to be a list. And here, this list has two objects in it, okay? There is sum, which is going to be a field, and it takes on the value 0. And then add, which is a function, okay? And so this will be the method. So this very simple R6 class object has one field, sum, and one method, add, okay? And note what is written in add, okay? So add is a function with a default value of x equal to 1, and what this does I ate some peanuts earlier. And now I'm like choking on peanut dust here. Okay. So what it does is it references this field sum. Okay, and the way it accesses the value sum inside the object is by calling self. Okay, and you do self $sum. Okay, so self $sum will be whatever value is stored currently in this field sum, okay? And we're going to say self $sum, add x, and assign that back to self $sum. So that this assigning back to here is going to update this value 0, okay? And then what it does at the end is it returns self invisibly, okay? All right, so when we do this and we call accumulator, we say this is going to be an R6, it's an object generator. It generates objects of type accumulator, and inside the public, we've got sum, and we have add, and then all R6 objects kind of come with some default methods that are available to us as well. There's going to be a clone method, a new method, and things like that, okay? And just some other information. All right, so here we create a new object called x, and we do this by calling accumulator $new. So this says, okay, you have defined this reference class accumulator back here, and to create a new instance of this thing, we call accumulator $new, and this creates x, okay? And when we ask x, it says this has the public function add. It also comes with clone, and it comes with a field sum 0, right? And then we can access the value in sum, right? We just say x $sum, and it says it currently has the value 0. All right, and then here I have x $sum, it's 0. If I call the method x $add, okay, the default value of add is it's going to add 1 to the sum, okay, and x $sum is now 1. If I call x $add 3, the sum is now 4, okay? And so notice this is different from what we're accustomed to in R, where that every time you call a function, it returns a value, right? And when you but here, and if you wanted to save that value that it returns or update something, you have to assign it somewhere, okay? With encapsulated OOP, or with R6, this, when we call add, it modifies the value of sum here, okay? So I don't have to say take add and then store it back somewhere, okay? I'm just doing x $add, and that's modifying the value of sum here, okay? All right, so if we take a closer look here, okay, the last line here is invisible self, right? So this is kind of in the definition of the accumulator class. This is kind of what it looks like, and we said add is going to it's going to look up the value of sum, which is stored in the public field, okay, and we get that by doing self $sum, and then the last line is invisible self, okay. So we know that our functions will return the object in the very last line, okay, in the function, right? So what this is doing is it's returning self, okay, invisibly. So invisible basically tells R, generally when you have it return a value, like if your last line in a function was x, then when you run that function, it's going to print out whatever x was, right? And you can also take that value and assign it somewhere. Okay? Invisible basically returns the object, but it doesn't print it out. So if you had a traditional R function with invisible, you could take the output and assign it somewhere, okay? It just won't print out when it runs, okay? So this is, we call invisible on this. And what this means is that whatever object we have, the object itself gets returned as the result of the function. Okay, so the result of calling add, the add method is basically the updated object. All right, so if I look at x $sum, it's currently the value 4, okay? And because I've returned the value self invisibly, I can chain the methods, okay? So basically, x $add 10 is still the object, the accumulator object here, okay? When I do x $add 10, it's going to update the sum to 14, but the result of x $add 10 is the object, is an accumulator class object, right? And therefore, I can call add 10 $add 10 again, okay? And so now I'm calling the method, the add method, and I'm adding 10 to 14 to this thing, okay? And so this thing, the result of this so far as well, is another R6 class object, because the method is constantly returning itself, okay? And then finally I can just say, okay, well, what is the value of the sum here? And it returns back 24. Right? Does that kind of make sense? The fact that I'm able to chain these methods. Okay, this is an important concept when you're doing encapsulated OOP. Okay, and this is I don't know if you've ever handled Python objects. Okay, but Python objects make heavy use of this stuff, okay? So when you're doing things in pandas and you're dealing with series, you will often chain all of these methods. You run something, and the result that it returns is another object with all of these methods, and you can kind of chain them. Yes?
So in the same way that like other object-oriented languages do private variables matter?
You do have the option to create private variables as well. Yes. Yeah. So we'll talk about that. Yeah.
If instead of invisible it was just return, if you chain it together, would it like return sort of the steps almost?
I think it'll end up printing the thing out, but not. I don't think it'll print it out every single time. I don't know. I'll have to. If we got time, we can play with that. Okay. Okay. So yes, by having invisible self, which is a recommended thing, at the end of this, you can do method chaining. Okay. So just kind of one recommendation is that when you do method chaining, okay, so you can imagine something like this becoming difficult to read. One recommendation is you add each operation kind of on its own line. So the steps of what it's doing becomes is a little bit easier to read. Okay, but I guess depending on what the function is, right? In the same way that when you pipe dplyr commands together, it's recommended that you put each function on its own line for readability. Yeah.
So at the end, when you do the two adds, if you didn't then again do $sum, would it just not return anything?
So if I didn't do $sum at the end, it would not print anything out. It would have updated the value to 44, okay, but it doesn't. But it returns it invisibly, so it wouldn't print anything out. Yeah, but the value inside is now updated to 44. Okay, so it's kind of like running that assignment thing. So I think thankfully, every time you run an assignment in R, it doesn't print out what you've just assigned, because you can imagine like all of your scripts just printing out like a monster, a ton of junk that you don't actually want. So yes, if I didn't call $sum, it wouldn't print anything out. But here I'm calling it, and it's 44. Okay. You are not required to create a method called initialize, but it's recommended that you do. Okay. So initialize. So every R6 object will always come with this method called new. Okay, and that just creates a new instance of whatever R6 class object that you've defined. Okay, and so here we are creating an R6 class called person. Okay, and the person consists of, it's going to have a name and an age. Those are two public fields. Okay, name and an age, and initialize is going to be a method, okay? And we know it's a method just because it says initialize equals function, right? And what initialize will do is that it will override the behavior new. You still use $new, but when you use $new, and the initialize function is defined, it's going to use this to do it, okay? And so basically in initialize, we have two checks, right? We have this command stop if not, all right? And so this creates an error if any of these things are false. So all of these things have to be true, otherwise it will create an error. So it's going to check, is name a character vector, okay? And then is name a character vector of length 1, okay? And both of those things have to be true in order for us to for it to work, okay? And then age has to be a numeric vector, and the length of age also has to be 1, okay? And if any of these things are false, stop if not is going to produce an error, okay? And then assuming it passes this, then it will take whatever we put in for name and assign it to self $name, and whatever we have for age, it's going to assign it to self $sign age. Okay, it's going to assign it to those fields. All right, and so here we run person $sign new, okay, and we give it the name Hadley. Age, we put in character 38, and then it produces an error, right? Because when we call new, it runs this, and this becomes this is false, right? Stop if not. So it says is dot new numeric, and then it's going to say is false. Okay. Whereas here I can run person $sign new, Hadley age equals 38, and it does it. Okay. No errors here. So this means this object was created successfully. Okay. And then if we call Hadley, it's going to, or not call it, but just type in the name. It's going to print out the object. Okay, this is the default way that an R6 object gets printed. Okay, it kind of lists, it writes out the class name, and then it lists off everything in public. Okay, and I think it also lists off everything in private and all of that. It just lists everything out. Okay, and so you might want to define a print method, right? So that this object is going to print out the way you want it to print. Okay. So to do that, you're going to just define basically a print method inside one of the inside the class here. Okay. So here we're going to define our class a little bit more. We've got class name is person. The public is a list. We still have the two fields, name and age. But now we have initialize, which we defined earlier, and then we have print. Okay, and so print is a method, and when we call print, it's going to cat the person's name with a new line, cat person with a new line, and then it will cat the name with self $sign name, new line, cat age with self $sign age, new line, and then again return itself invisibly. Okay, and so now we initialize a new person to Hadley 2, and then when we print out Hadley 2, it prints it out using the print method. Okay, and so it says, here's a person, name is Hadley, age is 38. Okay. An important thing is to remember is that methods are bound to the R6 objects themselves. Okay, so when we created the first instance of Hadley, okay, that was created with an R6 where we did not have the print method defined. Okay, and then we created Hadley 2 with an R6 that did have the print method defined. Okay, these methods are bound to the objects themselves, so the old Hadley doesn't suddenly get this new print method that we've created. Okay, so here is Hadley 2. When I print it out, it looks like this. Here's the original object that I created, Hadley. Okay, now it might feel a little strange because both of these are of the R6 class person. Okay, so but we just have to remember that there's no relationship between the objects Hadley and Hadley 2. They just happen to share the same class name. Okay, and so we can see how this can end up becoming confusing. And so if you are like working, okay, and you are trying to develop how you should define your class, right? As you're working, anytime you update your definition of the class, you should delete all of the old objects, okay? And that way everything, and then redefine your objects using the new class definition. Okay. Otherwise, you're going to have, this instance of a person class, okay, and this instance of a person class, and they've got different methods associated with them. Okay. R is fine with this because it sees the methods themselves are tied to the objects. Okay. The methods are completely enclosed in the objects, and so it's fine. And we're not going to run into problems with generic functions, okay, with generic functions, it's going to look at the class of the object and say, all right, this is the kind of function that I need to use. But there's no generic functions here. The functions, the methods are tied directly to the objects. So it's not going to cause issues. But it's going to be confusing for you as the user. So get rid of your old objects and redefine them. That's the recommendation. All right, is that all right? Okay. It is possible to update, okay, add methods to an object or to an existing class after it's been created, okay? So, for example, this is, I don't know if this is the best way to do it, but here I've defined a new R6 class with basically class name accumulator, but with no public list here, okay? But here we're going to say, all right, add a field sum with value 0 to public, okay, the public list, and then add a function add, okay, with this definition to public as well, okay? And you use this using $set to the class definition itself. Okay. I don't know if this is the best approach, but you can do it this way. All right, so R6 also supports inheritance, okay? So inheritance is kind of the idea that you have this parent class, and then you have these children classes that inherit from the parents, okay? In that the child class will basically behave the same way as the parent, but maybe you modify things slightly differently, okay? So just one example of this, okay? Again, this is, I have to give credit to Hadley, is that he defines a new class called accumulator chatty, okay? So this is kind of the idea of being verbose, right? So it's basically it inherits from the accumulator. So the accumulator is that very simple R6 class where you've got a sum and the method add, okay? And notice what we have done inside the public list, okay? So the public list does not bother containing sum because it's going to inherit sum from the parent class, okay? So we don't bother including sum here because anything that I don't put in here, it's just going to inherit from the parents, okay? And then, but what I do is I change the method add, okay? The method add looks the same. Well, it's different, okay? Add takes in a function of x with default value 1, and it cats to the screen adding x with a new line, okay? So just kind of, it's like a verbose statement. It just says, hey, this is what I'm doing, okay? And then notice what I do here, okay? Rather than redefining the entire function again, where I say self $sum is equal to self $sum plus x and return invisible self, okay? Rather than having to redefine all of the contents of that, I'm going to say, you know what I had there was good, okay? What I had there was good. And so just call the original add method, okay? And the original add method inside this, the parent class, or what we're going to call the super class, I access by doing super $add. Super $add x equals x. Is that okay? The reference to the super class, okay? So I don't have to copy and paste the entire, right? So in programming, you generally want to avoid copying and pasting, because when you copy and paste, it means this code is perfectly good and I need to reuse it somewhere else, okay? But then that means, I just want to tweak something that, this perfectly good code, I want to tweak it a little bit. Then you're going to have to remember where you copied and pasted that, and you're going to have to copy and paste those changes, right? So rather than copying and pasting, we're going to just say that original function where I'm adding something to self $x, that's good, Okay, I like it as it is. Okay, and so rather than copying and pasting, I'm making a call to it, and I do super $add x. Okay, and then so the only difference between add and the original add is that we have this additional line where we cat some stuff to the screen. Okay, and so so here I'm going to define a new instance or accumulator chatty. We call this x2, and then we do add $10, add $1, or $add 10, $add 1, call the sum, and each time it calls, it cats stuff to the screen and says adding 10, adding 1, and we get the final sum result of 11. All right, okay. No one's saying anything, so I hope that's good. Okay. Oh, I guess this is just me writing out everything that I said here. Okay. When you when you ask class on some object, it's going to tell you the class name. So here we class Hadley is person, R6. Hadley 2 is person, but these, again, it's confusing for the user. It's not confusing for R because the functions or the methods are tied to the object. But for us, this person definition is different from this person definition, right? The first one doesn't have the print method. This one does. Okay, and then for x2, because it inherited from accumulator, it's going to have accumulator chatty inheriting from accumulator, and they all inherit from R6, okay? And that just, by inheriting from R6 originally, that includes the methods for new and clone and, you know, all of the kind of the original methods that are available to us. Okay? If you want to see the methods associated with an object, okay, you can just call names on Hadley, and it gives you all the fields and methods available. So here we have the fields age and name, and then it has the method clone and initialize, okay? And then names for Hadley 2, which is from the second definition of the person class. We have age, name, clone, and then we also have the print method as well, okay? All right, is that okay? All right, so a big thing is that with reference class object or R6 objects is that we have reference semantics, okay? So most of what you're accustomed to is that R uses what we call copy on modify, okay? So in the following code, I write A is C12, okay? It's the vector 1, 2, and then we're gonna take A and do B, and then we're gonna change B here, okay? So basically what we're doing is we are binding the name A. So you remember back to the, I don't know, the lecture on environments. We bind the name A to this object, this value 1, 2, or the vector 1, 2. Okay? Then we bind B to the same object as A. That's what we do here. Okay? And then what happens is when we modify B, and I say take element 1 of B, add 10 to it, and store it back to B, okay? What happens there is R creates a copy of the object and modifies it, okay? R does copy on modify. So when I say assign this back, R is going to say, wait a second, I'm going to create a copy, then I modify the object, and then so that way A remains 1, 2, and B is now 11 and 2, okay? And this is what we're used to, right? So this is no surprise to anybody, okay? This is called copy on modify. All right, notice what happens when we use reference semantics, okay? Here I create a new accumulator object X, okay? Then I bind the name X to this thing, right? Then I bind Y to this object X, okay? To the same object as X. And now I'm going to modify Y by calling the method add 10, okay? I call Y $add 10, and we go, okay, that's going to add 10 to the accumulator object Y. But because Y and X are both have the names pointing to the same object, both $X$sum and $Y$sum show the value 10, okay? And that's because x and y, x $ sum and y $ sum, are the exact same object and same value, okay? This is reference semantics. So doing this, you know, you might have thought, like, I'm adding 10 to y but not x, okay? Because that's how the rest of R behaves, okay? That's not how it works with reference semantics, okay? Y is pointing to the same object and x is pointing to the same object. Is this okay? The difference between what happened here and what happened here. Okay? And so if you wanted to have a copy, you have to use the function clone, okay, or the method clone, right? So here I create a new accumulator object, class accumulator object, and we call we're going to bind the name x to it, and then I call clone, and then I bind the name y to the clone of x. Okay, so when x is initialized, it takes on the value 0. Okay, and so here I can add 10 to y. Okay, and then we can see that y sum is now 10, but x sum remains 0. Okay, because x and y are now different objects. X points to this object. Y was originally a clone of x, but now we are now it's different, right? It's like, I don't know. They're different objects, okay? They're clones, but they're different. They have different values here, okay? One thing is that reference semantics can be tricky, okay? Reference semantics can be tricky. We're always accustomed to saying, you know, a function always returns a value, and if you want to use that value, you've got to assign it somewhere, okay? But with reference semantics, you can have a function. When you call a function, I wrote this wrong, but if these were reference objects, the function itself could modify the object, or it could return a value, okay? And that can get confusing because now you're no longer sure what exactly is happening. So the recommendation is that when you have a function that interacts with R6 objects, okay, the function should either return a value but not modify the input R6 object, or it should modify the input R6 object but not return a value, okay? And this will help you avoid confusion. All right, so just an example is I've got two different functions here, okay? Here I'm going to create a new accumulator object x, and I've got one function which is going to be add 5 to the sum, okay? And this interacts with the accumulator object by calling the add method and adding 5. So this is an object that's going to modify the input object x, okay? Over here, the sum times 10 is going to access a value and multiply it by 10 and return the value, okay? So so here when I call add 5 to sum, this is the call to the function. It doesn't return anything to the screen, but when we check x $sum, we can see that it has modified the value to 5, okay? Here, sum times 10x gives me 50, okay? But x $sum remains 5 and is unchanged. And so if I want to make use of this value 50, then I've got to save it somewhere, okay? I've got to save and store it somewhere, right? So it's possible to write a function that's going to do both things. It's going to add 5 to it and return a value, okay? And you can do that. There's nothing in the rules that say you can't do this. You can do that, but it's going to often make things a little bit harder to think about, okay? So recommendation is they should do one or the other, but not both. Okay, I'm probably going to run out of time here, but if you're familiar with object-oriented programming from other languages, there's this concept of public and private. And I guess I'll include this here, and I will just put a note that I will not test you on section 4, the public, private, and active stuff, but I want to include these notes here. And when I release the homework for the Monopoly, don't just pack up now. when I release the homework for this next assignment that uses R6, it can be done entirely with just public stuff, and this information about private and active is not necessary to complete the homework assignment. Okay, but I do want to include this here. All right, and so when you create an object, there's something known as private fields. Okay, private fields mean that these values or methods are available only from inside the object, okay? That you cannot access them from outside the object, okay? But one thing to note is private does not mean secret, okay? So it doesn't mean that these things are secret things. You know, people, like if you create them, you can still look inside and figure out the values of these things. It's not a secret. It's not like this encrypted system, okay? It just means the values are inside, but they are private, okay? Meaning that they cannot be accessed from outside, all right? So, so here, just an example, here's the person where we've defined name and age to be public, okay? And so here I can look at this age, and it says 38, and then from outside the object, I can just say take 25 and assign it to Hadley $2 and it gets modified to 25 here, okay? Over here, okay, okay, so this is the definition of the thing. What I've done is I've moved the values age and name into private, okay? So public still has initialize and print, but inside I've moved age and name, those fields, into private, okay? And so here I can define a new person, Hadley 3. Hadley 3, this is going to be the private person, okay? And so the name Hadley and age go here, but then if I try to access $age, it returns back null, okay? And if I try to assign or modify that value, it returns back an error, okay? And Hadley 3, the value is still there, okay? The value is there, it's just you cannot access it directly, okay? So trying to access the age directly returns a null, trying to modify it directly returns an error. Okay, so that's what a private field does, and it just kind of helps ensure that outside stuff is not going to mess up things internally, right? So internally, you might have values that are in some kind of formatted list, okay, a list of certain things, but outside, somebody can come in and just change it to a vector and break your code, all right? So by putting things in private, you can prevent that, okay? There's also something called an active field, okay? An active field looks like a public field, but that value, the value that it returns and looks like a public field, is actually generated by a function, okay? So this might be a little weird, but so here we create a class called rando, all right? And basically, there's no public fields available, but we create an active field, okay? And inside the active field, we have this value random. The value random returns one value from our unif, okay? Some one random value from our unif, okay? Active comes, the functions always are a function of value, okay? And if it's missing, it's going to kind of retrieve or pull out this value. And if it's not missing, then it's being modified, okay? So in this case, like when you do something like this, trying to assign 25 to age, then it's basically supplying a value here, all right? So here, if we call random, it generates new random values here, okay? So in practice, active fields are often paired with private fields, okay? So you might have something like name and age stored in private, okay? But you have them generated by active fields, okay? So for example, what we're gonna do is we define our person here, okay? And we have the age and name, and we call these .age, .name, okay? These are private fields, and this is where we're gonna store the name and age of the person, okay? But to make it look like we can access the age and name publicly, we create active fields, okay? And so what the active field age does, or let's just look at the active field for name, if if we're not being supplied a value, that means we're retrieving the value, and it's going to look up private $name. Okay, so it's going to retrieve the private value here. But if it's being supplied a name, as if we're trying to modify the name, it's going to do a check. It's going to check to see if it's character. It's going to check to see if the length is 1. And if those things pass, sorry, I don't know why I have this blanked out here. Then we're going to take the value and assign it to private.name. Okay, so you can read through all of this, and I'm just going through this quickly. But here we have we've created a new person, Hadley. Okay, and like a public field, we can say Hadley $name, and it returns the name Hadley. Okay, and then like a public field, I can take the name Wickham and change it, and we've modified the name Wickham. But because it's an active field, if I try to take the value 10 and assign it to the name, what it's actually doing is it's running through the function, and it's going to say 10 is not a valid name, right? So inside the active field, we have this thing that says, is it character? And if it's not a character, it's going to return an error. And so when we try to do this and put 10 inside here, it gives back an error, and it retains it. So it looks like an active field in that you can do $name and you can assign values to it, but what it's actually doing is it's running a function that validates the input before it overwrites the thing. Okay, and so that's a possibility to do with active fields and private fields and working together there. Okay, we'll end there, and we'll see you guys on Friday.